This is Geometry B, Unit 7, Lesson 5, Circles in the Coordinate Plane. I've got GeoGebra open because it's a really good application to use for circles. So I'm going to write an equation, and we're going to explore what shape it makes. So here it goes. X squared plus y squared equals, let's say 3 squared. Okay, and look at the shape, and hopefully you can identify it as a circle. Take a look carefully and tell me what the radius of the circle is. Yeah, I can zoom in a little bit, hopefully, and change the scale. No, it's not going to change the scale. But the radius, hopefully you can tell, is 3. It goes through the point 3, 0, 0, 3, negative 3, 0, and 0, negative 3. This introduces an idea. That is that a circle, the equation of a circle is x squared plus y squared equals r squared. Now that sounds familiar. If it sounds familiar, it's because it is. You're familiar with the Pythagorean theorem, which says a squared plus b squared equals c squared, in which a and b are the legs of a right triangle and c is the hypotenuse. It is the Pythagorean theorem, and it's at the root of the distance formula. And a circle is defined as all points equidistant from one point. So the distance formula has a lot to do with the equation of a circle. All right? So that's really kind of interesting. Now, there's one more thing you can do with this circle. You can translate it. You can move it. Okay? And remember this. If I replace x with x plus or something, then what that does is it shifts everything left and right. It actually shifts it to the left. Let me do a little experimentation here with this. So let's replace x, and I'm going to leave the original circle here and zoom standard here. But let's replace x with x, say plus 2. Squared plus y squared equals 3 squared. Okay, same circle, but the circle has been shifted to the left 2 spaces. If I make this a minus 2, it'll be shifted to the right. So I want you to remember this. Whenever I replace x with x plus something, it'll shift it to the left, and x minus something will shift it to the right. The same thing is true of the y value. Let's say I replace y with y plus something. X squared plus y plus 2 squared equals 3 squared. Notice it makes the same circle, but the circle is shifted down. Okay? So kind of think in terms of opposites. So that brings out this formula right here. X minus h squared plus y, or actually minus, let me put minus, and the minus is because it has the opposite effect of what you might think. Minus h will actually move it right h units, not left. Okay, y minus k squared equals r squared. That makes a circle of center hk and radius r. Radius r. Okay, let me demonstrate again here. So let's say I do this. I replace this with r. I replace this with k. And I replace x with x minus h. And actually, we want minus k. Minus k. All right. And I'm going to add sliders here for all of these. Okay, and I'm going to set the radius to 2. So that it's the same, or a radius to 3 actually. 3, okay. And now as h gets bigger, the circle moves right. As h gets smaller, the circle moves left. As k gets bigger, the circle goes up. As k gets smaller, the circle goes down. Okay, and we can use this to cause the circle to dance all over the place. And if we bring in r here, we can also make r dance here. Well, not allowing me to for the moment for some reason. Okay. All right. So that's the relationship. So we can use this to graph circles, right? So let's say, for example, I want the equation of a circle. I want the equation of a circle with center 4, 1. And I want it to have a radius of 5. Radius of 5. So there we go. So 2, 4, 5. So I want the equation of this circle. So the radius is 5. So the equation of the circle would be x minus 4 squared plus y minus 1 squared equals 5 squared. Or x minus 4 squared plus y minus 1 squared equals 25. Okay, let's verify that in Desmos. Verify that it works. Did I close Desmos? Apparently I closed Desmos. Got to open a new copy of Desmos. Oh, Desmos. All right. So here we go. So we're going to graph x minus 4 squared plus y minus 1 squared equals 25. And see if that makes it. And I'm going to graph the point 4, 1. And there it is. There's the circle, 4, 1, and a radius of 5. All right. And now one thing, one caution, word of caution. Let's say this is one where we're given the graph and write the equation of the circle. What about if you're just given the equation of a circle? Let's say we have x plus 3 squared plus y minus 2 squared equals 16. Okay, what is the center of the circle? Well, look to opposites. Remember, it's x minus h, y minus k, so it needs to be opposite. So the center is at the opposite of plus 3, which is negative 3, the opposite of minus 2, which is 2. And the radius, remember 16 is not the radius. Okay, the radius squared is 16, so that means the radius must be the square root of 16. 4 times 4 is 16, so the radius is 4. Okay, so that's a word of caution here. The radius squared is 16, but the radius is 4. All right, hopefully that helps.